Hi class, here we go again. This is lesson 5.5, doing problem 85. And here we're just basically trying to find the solution of the equation. It doesn't really give us much help or many guidelines, but it says we need to find all the solutions in this interval. Okay, no problem. Well, with experience and practice, you start to recognize things like, for example, here we have a sign plus another sign. So, if you've got that formula sheet in front of you, hopefully you notice that there's another formula here that has sign plus sign. So it could be that that formula might come in handy, and actually it does. So let's check this thing out. Let's see what happens. So let's plug in. So the 6x is our alpha, the 2x is our beta, and so let's just plug this whole thing in. So we have 2 sine, let's see, 6x plus 2x over 2 multiplied by cosine 6x minus 2x over 2. Okay, so that's just using the summed product formula. All right, let's simplify it a little bit. 2 sine 6x plus 2x is 8x divided by 2, 4x. Cosine 6x minus 2x, 4x divided by 2 is 2x. Okay. All right, so now don't forget, this is an equation. So this is equal to 0. Don't forget about that. So we're trying to solve for x values. And so if something times something equals 0, that means either this part is equal to 0 or this part is equal to 0. Okay, so there's basically two equations there. So we've got sine 4x equals 0. Let's do these one at a time. I'll use green for this first one. Okay, so that means we're looking at our unit circle, and basically we should have the sine value is the y-coordinate. So where's that? It's happening here and here. These are the 2 points where the y-coordinate equals 0. So what we have is 4x equals 0 and pi. Now, of course, if we had coterminal angles, we can go even farther, right? So we have 0, we have pi, we also have 2 pi. So we could technically write 2 pi in here, and we could go even farther. That would be 2 pi, that would be 3 pi, and 4 pi, and 5 pi, and etc. It just kind of goes on and on like that. Now, I know that our interval is only from 0 to 2 pi, but we have to be careful when we're working with multiple angles like this. We've got to just see the pattern, see how far it goes, and then we solve for x. So x equals, divide everything by 4. So 0 divided by 4, and then we have the next one, pi divided by 4, and then we have 2 pi divided by 4. I'll just write it out that way. And then 3 pi divided by 4, and then 4 pi divided by 4, and etc. Keep going. 5 pi divided by 4. Oh wow, 6 pi divided by 4. We could just go on and on like this all day, couldn't we? Okay, 8 pi divided by 4, etc. Dot, dot, dot. Now, we actually have to go a long ways out there because think about our domain. We have to go from 0 to 2 pi. So the x values we care about are actually all of these ones. 0, we need. Pi on 4, we need. It's in the domain. This next one is simplified to pi over 2. That's in the domain. 3 pi over 4, that's in the domain. All of them, that's just pi. 5 pi over 4. That one's 3 pi over 2. This one's 7 pi over 4. And finally we get over here to 8 pi over 4, which is 2 pi. But you can see because it's got a curvy bracket here, that means we don't include it. And so this is enough. So these are all these solutions come from that one side of the equation. Wow. Don't forget all of them. So you're going to have to, when you've got these multiple angles, really you know how far you have to go. You have to go 4 cycles, right? So you've got 1, 2, 3, 4. That's how many cycles you need to worry about. Anyways, so that all comes from the sine 4x, all those solutions. Wow. Okay, let's try the other side. So same idea, we've got cos 2x equals 0. So let's think about the unit circle again. Where's the cosine equal to 0? Well, it's up here at pi over 2 and down here at 3 pi over 2. So we have 2x equals pi over 2 and 3 pi over 2. But again, we have coterminal angles. So there's pi over 2, there's 3 pi over 2, but don't forget we could go all the way around and come back up to here as well. And what would that one be? So 1, 3, that would be 5 pi over 2. And then after that, we would have 7 pi over 2. And after that, we'd have 9 pi over 2. You can see a pattern going on here. 11 pi over 2, etc. dot, dot, dot. So we could keep going and going and going. There's lots of solutions. But then we need to also solve for x. So x equals pi over 2, which is pi over 4. So we're dividing by 2 here. So this one would be 3 pi over 4, and 5 pi over 4, and 7 pi over 4, and 9 pi over 4. Okay, so again, that keeps on going and going and going. But with this one, same with both of them actually, we have to check again to see if it's more than this upper limit of 2 pi. Well, this 9 pi over 4, that's already more than 2 pi, right? Because with the common denominator, 2 pi would be 8 pi over 4. So really we just have these solutions here. Just. There's 4 of them. Oh wow, so that is a lot of solutions. In fact, how many unique solutions are there? Because we should probably check that, because here's a pi over 4, and here's also a pi over 4, so we've counted that one twice. And here's a 3 pi over 4, and here's a 3 pi over 4, and here's a 5 pi over 4, 5 pi over 4, 7 pi over 4, 7 pi over 4. Okay, so let's just write down one last time all the solutions that are like the unique ones. Okay, so 0 is unique, and then we have pi over 4. Okay, that takes care of, let's cross them off so we don't forget any. Pi over 4, and then we've got pi over 2. That crosses that one, and then we've got 3 pi over 4. That's that guy. Then we've got pi, and we've got 5 pi over 4. And then we've got 3 pi over 2. Wow. And finally, 7 pi over 4. Whew. That's a lot of solutions. Now I definitely, with all this math on the board, I definitely want to verify with my calculator to make sure that this kind of makes sense with the picture. And I've already graphed it for you. We check here, I've typed the whole equation in, the first equation, sine 6x plus sine 2x. And I'm going to show you the window settings from 0 over to 2 pi. Alright, and let's see what we find here. Wow, crazy graph. How many solutions do you see here? We got the one at 0 as 1. Oops. Oh, what did I do? Oh boy. I didn't want to do that. Okay, sorry. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. 8 solutions total, and how many did we count before? 1, 2, 3, 4, 5, 6, 7, 8. So at least that part makes sense, and you can go and use your calculator to determine exactly, to make sure all those solutions are the same ones we came up with, but at this point I'm pretty sure. So yeah, rewind and watch this one again if you're having some troubles, or ask your neighbor, or put your hand up. I will come over and help you out as well, and good luck.